Okay, welcome back students. Next question is NFA to DFA with Epsilon conversion. Okay, so the last video we discussed about how to convert NFA to DFA without Epsilon. If you are having any doubt, please check the previous videos I already shared. Okay, so this is NFA to DFA with the Epsilon. So your NFA having Epsilon as a inputs. Okay, so this is one of the example. Q0 to Q9 states they may give. Q9 is the final states. So for that you have to find all the epsilon closure for all the states. Okay, so how to find the epsilon closure? Epsilon closure, it is very easy. So if you are finding one state epsilon closure means first write the same state. If you are finding epsilon closure for Q1 means Q1, Q2 means Q2. So this is first you have to write. Okay, similarly you have to write for the remaining all the states. Okay, so this is first step. Next you can check Q0 with the input epsilon, where it will be go. Q0 with the input epsilon, it will go to Q1. Continuously with the input, where it will be go, it will go to Q2. Continuously with the input epsilon, it will go to again Q4. There is no outgoing. Okay, so this is only, and from here also this is going with the input epsilon, it will reach Q7, and Q7 there is no outgoing with the input epsilon. So this is the epsilon closure for Q0. Okay, so this is Q0 epsilon closure. Similarly you have to do for the remaining Q1 with the input epsilon, where it will be go. Q1 with the input epsilon, it will go to Q2. Again there is any other outgoing in the Q1 no. Okay, Q1 with the input epsilon will go to Q4. So this is the epsilon closure for Q1. So similarly you have to do for the all. I will write. Okay, I write all the remaining epsilon closure, and this is you have to rearrange in the ascending order. Okay, so this is also you have to rearrange in the ascending order. So this is the epsilon closure for all the states. Okay, so this is first step. Then you can find the step 1. So step 1 is del dash of a comma 0. A is nothing but you can take the epsilon closure for starting state Q0. Starting state, what is this? Q0 is the starting state. So epsilon closure for Q0, you can take this is A. Okay, then you can process with the A with the input zeros and ones. Here you are having input zeros and 1 and epsilon. So you have to process with the A with the 0 and 1. Okay, so you can process with A with the input 0. So del dash of a comma 0, the formula is epsilon closure of a del of a comma 0. So epsilon closure of del of a values we know in the first epsilon closure of Q0 value. Okay, so I write this value. Then you can find epsilon closure of del of a naught Q0 with the input 0. Q0 with the input 0, where it will be go, there is no. So that is you can mention like 5. Okay, union Q1 with the input 0, where it will be go, again union Q2 with the input 0, where it will be go, union Q4. So the same you can do for the remaining. Okay, so I will write Q1 with the input 0, it will go to Q3. Q2 with the input, it will go to 5. Q7 with the input 0, it will go to Q8. So this is enough. Okay, then you can write epsilon closure of, you had Q3 and Q8 only. Epsilon closure of Q3, what is that? Or epsilon closure of Q8, what is that? You have to write epsilon closure of Q3, this is union epsilon closure of Q8. Q8 this is only. Okay, you can mergely write this. Okay, so this is you got Q1 comma Q2 comma Q3 comma Q4 comma Q6 comma Q7 and Q8. So this is one new state. You can take this state as a state B. Okay, then you can process with the del dash of a comma 1. So you can write the del dash of a value with the processing 1. You got some value, then you can take another one state. Okay, if you are processing with that, you got I think Q1, Q2, Q4, Q5, Q6 and Q7. Okay, you can check your one. If you are processing with this value, you got this value. Okay, so this is I am taking, this is state C. Okay, so we got again new two states. Then next step, this is step 1. So step 2, you have to process with the state B with the input 0 and 1, state C with the input 0 and 1. Next, state B with the input 0, state B with the input 1. If you are processing with the state C with the input 0, you got Q1, Q2, Q3, Q4, Q6, Q7, Q8 and Q9. Okay, so this is also one new state. I am taking this is a state D. Okay, and if you are processing with the B value with the 1 means you got Q1, Q2, Q4, Q5, Q6, Q7. This is also we got in the state C. So state C similar to the, this is only the same states we got. So this is state C. Okay, so B processing is finished. Then you can do with the C and D with the processing of 0 and 1. So if you are processing with the C with the input 0, you got the state B only. Okay, if you are processing with the C with the input 1, if you are processing with the C with the input 1, you got again state C only. Okay, if you are, then you can do with the state D the same processing. If you are processing with the D with the input 0, you got state D only, same states you got. Okay, here also if you are processing with that, you got state C. Okay, you can process with the same steps if you got some answer. Okay, then you can convert that to the transition table and transition diagram. Okay, then you can write del dash of starting state to final states. Okay, if you are processing with the A, what are the states you got? If you are processing with the A, you got B state only. If you are processing with the A, you got C. So you can fill using the processing DC, BC and DC. Okay, then you can make the transition connection. A process with the input 0, it will go to B. A process with the input 1, it will go to C. Similarly, you can draw with the remaining. This is the finalized diagram. So this is, we have converted NFA to DFA without epsilon. Okay, I hope you can all understand. Please try it, is your own, then only you can be able to do. Okay, thank you students. We will see in the next video. Bye.